Welcome to The Explainer. So, today we're diving into a really cool new AI model, one that could completely change how doctors find and understand medical images. We're talking about turning a super frustrating search into potentially a life saving discovery. All right, here's what we're going to cover. First, the massive image overload doctors are dealing with. Then, how we've been teaching computers to see and why a smarter search is needed. We'll look at the super trainer they built, see how it performed, and finally wrap up with why this really matters to you. So, let's start with the problem, and it's a big one. Think about it. Every single day, hospitals are creating this absolute flood of digital images. It's like trying to find a needle in a digital haystack. How on earth does a doctor find that one critical scan they need right now to make a diagnosis? And to really test their idea, the researchers put together a database with over 1,100 different images. We're talking X-rays, CT scans, MRIs, the whole shebang. Now, this isn't just a random pile of pictures. It's designed to mimic the huge, messy, and super varied collections that real doctors have to dig through every single day. You know, the old way of doing this was, well, pretty painful. Someone literally had to sit there and manually type out descriptions for every single image. As the researchers here put it, that process is laborious and monotonous. I mean, can you imagine? It's slow, it's exhausting, and worse, a few lines of text just can't capture all the complex details you might see in a scan. A lot gets lost in translation. Okay, so manual tagging is out. The obvious next step, right? Let's get computers to do it. But as it turns out, the first generation of AI, well, it had its own problems. So these early AI models, called convolutional neural networks, or CNNs for short, they were a huge leap, but they had this one really big Achilles heel. See, they look at an image, but they kind of summarize parts of it to save space, and in that process, they can lose important details. This means they get totally thrown off if an image is just slightly rotated or tilted. Think about it. In the real world, medical scans are never perfectly aligned. So if a slightly tilted X-ray completely confuses the AI, that's a massive problem. All right, so that brings us to this new research, which comes up with a really smart two-stage solution to get around that whole rotation problem. It really is a 1-2 punch. First, the retrieval stage. The system just blitzes through a massive database to find all the images that look similar to the one you're interested in. Then comes the second punch, classification. It takes those images it found and tells you exactly what you're looking at, what kind of scan it is, or what condition it might be showing. Find, then identify. Simple but powerful. So what's the secret to that super fast retrieval step? It's all about creating what you can think of as an image fingerprint. It's this unique digital signature for every single scan, based on all its textures, patterns, and gradients. It's what allows the computer to really understand an image and compare it to others in a meaningful way. And this isn't just any old fingerprint. The model creates this really powerful new version called Old GWP. What's so special about it? Well, it cleverly combines the best parts of two different texture reading techniques. So you end up with a much, much richer and more detailed description of the image than you ever could before. Now, for that second part, the classification, the system uses a much more advanced kind of AI brain. It's called a CapsuleNet. And here's the key. Remember how those older CNNs got totally confused by rotated images? Well, CapsuleNets are built differently. They use these things called capsules to actually understand an object's properties, including its orientation. So tilt the image? No problem. It's a direct fix for that old critical flaw. Okay, so you've got this awesome fingerprinting method and this super smart classifier. But how do you tune them to work together perfectly? Well, you hire a super trainer. And this is the really cool part. This trainer is inspired by two of the ocean's top predators. This is so clever. They basically created a hybrid algorithm by smashing two nature-inspired techniques together. On one hand, you have the shark smell algorithm. Just like a shark homing in on prey, it's fantastic at a really focused search, zeroing in on a good solution fast. On the other hand, you have the whale optimization algorithm, inspired by how humpback whales hunt. It's amazing at exploring the entire ocean, so to speak, to find the general area where the best solution might be. You get the best of both worlds, broad exploration and sharp, focused hunting. So this new combo algorithm, the SSWOA or shark whale algorithm, acts as that super trainer. Its whole job is to fine-tune everything. It pushes the fingerprinting part to be as descriptive as possible, and it trains the CapsuleNet classifier to be as accurate as it can possibly be. It's the coach that gets the whole team to peak performance. All right, so the theory is fantastic. A shark and a whale working together to train an AI. Sounds great, but does it actually work? Well, the results are in, and yeah, the numbers speak for themselves. First up, just plain old accuracy. When they put it head-to-head against 4 other recent advanced models, this new system came out on top. It achieved a 97.3% accuracy. That's not just good, that's incredibly impressive in this field. But here's where things get really wild. The biggest jump was in something called the F1 score. Now, this is a super important number. It's not just about how often the model is right, it's about the quality of its answers. It measures the balance between being precise and not missing anything important. In medicine, that's what you really care about. Just look at this. In one comparison, the new system improved that F1 score by, get this, more than 54%. That's a staggering improvement. It shows this isn't just a tiny bit better, it's a massive leap forward in making an AI tool that's actually reliable enough for doctors to trust. Okay, so the numbers are amazing. The tech is cool, but let's bring it back down to earth. What does this actually mean for you, for me, for doctors and patients in the real world? Well, for starters, it means speed. A doctor could find similar cases to what they're seeing in seconds, not hours. That's huge. It also means more accuracy, which reduces the chance of misinterpreting a scan and leads to a more reliable diagnosis. For researchers, it's a game changer. They can analyze these huge databases of images way more effectively to find new patterns in diseases. And all of this, it all points to one thing: better patient outcomes. Faster, more accurate diagnoses simply lead to better, more timely treatments. So, at the end of the day, this is a powerful new tool, a new lens for medicine. And it really just leaves us with this one big, exciting question. What other medical mysteries is AI going to help us solve next? Thanks for watching The Explainer.